Okay, so our next section is mutually exclusive events, still continuing with probability. So we're going to start with the Explorer. Let's say that Carlos drew a single card from a standard deck of 52 cards. What is the probability that the card he drew is either an 8 or a black card? So what this section does is it actually combines set theory, which was chapter 3, and chapter 4, which was the combination permutation, with chapter 5, which is probability. Okay, so we're going all the way back to Venn diagrams. This stuff's really not that bad. So let's start with a Venn diagram. Is it possible that you have some overlap between 8s and black cards? Okay, so what's the overlap? 2. There's 2 that overlap. How many 8s then are there that don't overlap? And black cards? 24, right. Because there's 26 black cards in total. 2 of them are 8s. So it means there's 24 other cards. So the probability of the card being black is what? Well, probability of the card being black?
24 was 52.
26. Thank you. 26 out of 52, because there's 26 black cards and 52 cards total. The probability of it being an 8 would be 4 out of 52, because there's total of 4 8s and 52 total cards. So now the probability of having an 8 or a black card. So remember that this U means or. So when we figure that out, we take the probability of having a black, add the probability of having an 8, and subtract the overlap, or the probability of having a black and an 8. So the probability of black is 26 over 52. Probability of an 8 is 4 over 52. Probability of having both, which is our overlapping part, is 2 over 52. So we add these up to get 30, subtract 2 to get 28 over 52 is our probability of having an 8 or a black card. So we've got these things called mutually exclusive events, where 2 events are mutually exclusive if they cannot occur at the same time. So that's important. Cannot occur at the same time. So the example we just did here, are these mutually exclusive? Is there a way that you can have an 8 and a black card? Yes, you could have a 8 of spades. So these are not mutually exclusive because they have an overlapping area. So mutually exclusive would be, in a Venn diagram, 2 separate circles that do not overlap. If 2 events are disjoint, then the probability of them occurring at the same time is 0. So if you have 2 Venn diagrams that look like this, they've got no overlap, so the probability of overlap is 0. For example, you can't draw a heart that is a diamond. Those would be mutually exclusive. So if 2 events are mutually exclusive, then the probability of either occurring is the sum of the probabilities of each occurring. Or this is what that means. If they're mutually exclusive, you can just add the probability or what's in each circle together. But if they aren't mutually exclusive, that's where you have to do like we did here, where you'd add what's in the circle and then subtract the overlapping part. So our sample size, how many dice do we have? 3. Okay, 3. So we've got 3 dice. And what is the probability, or sorry, what, not probability, how many options are there for each dice?
6.
Okay. And what do we do with these? We multiply them together. Good. So 6 times 6 times 6 is 216 possible outcomes. Now, we're going to get back to B at the end. We're going to skip that for now. What is the probability of rolling triples? So all 1s, all 2s, all 3s, all 4s, all 5s, or all 6s? So the probability of rolling triples is actually, yes, 6 out of 216, because you only have one of each option for each dice. So you can either have a 1, 1, 1, 2, 2, 2, 3, 2, 3, Make sense? So there's 6 numbers, so that means there's 6 options. What is the probability then of rolling doubles? This one is not so easy. So how many possible numbers are there that you could roll a double with? 6, because there's 6 different numbers that could roll your double. But how many ways are there to arrange this set of doubles? 3, because you could have a 1, and some other number. You could have a 1, some other number, and a 1, or another number and 2 ones at the end. So there's 3 different ways that these doubles could be arranged within the set of dice. And then how about the last number, so x? How many different ways are there to pick x? Let's assume, right, that you can't have the same one, then it would be 5. So if we've already rolled 2 ones, this can't be a 1, but it can be 5 other numbers, a 2, 3, 4, or 5, or 6. So multiply these all together, and we get 90 for our favorable. So the probability is favorable over total, so 216. Now determine the probability of rolling doubles or triples. Are these mutually exclusive? So is there overlap?
Yeah.
Give me an example.
You can have, well, in the triple.
So these events are mutually exclusive because you can't have a double that's a triple, since we said that this last number is only 5 options. That means the option of the double is not included in there anymore. So since they're mutually exclusive, we can just add up our probability of double and our probability of triple. So our probability of doubles is 90 over 216. Our probability of triples is 6 over 216. Add them up to get 96 over 216. So now back to part B. The probability of not rolling doubles or triple would be the complement to this. So 216 minus 96 equals 120 over 216 would be your probability of not rolling doubles or triples. So we have Frank and Pete who are playing a board game. To move on this turn, Frank must either roll doubles or a sum of 7 with 2 standard die. What is the probability that he will move on this turn? So let's start by making a sample space. So we have the sum of 2 dice, just regular dice. So to solve this, first we filled in our sample space, and we circled all the doubles and we circled all the rolls of 7 and figured out the probability for both. Now, are these events mutually exclusive? Means, can you have a double that is a sum of 7? No. So you notice that we don't have any of these circled twice, so that means they are mutually exclusive. So if they're mutually exclusive, to find out the probability of sum of 7 or a double is going to be just adding them up. So 1 over 6 plus 1 over 6 is 2 over 6, which is 1 over 3, would be your probability that this guy can move on this term. So to find if Pete will receive a bonus on his next roll, let's go back to this and look at all the sums of 8. So this time I'm going to put squares around the sums of 8. So there's 1, 2, 3, 4, 5 out of 36 would be the probability of getting the sum of 8. But then we need a multiple of 5. So let's look here. Multiple of 5 would be, there's 4 5s there, and 3 10s. So 7 out of 36. Are these mutually exclusive? Can you have a multiple of 5 that is a sum of 8? No, because anything that equals 8 is not a multiple of 5. So therefore they are mutually exclusive. And how do I figure out mutually exclusives? Just add them up, right? So we get probability of having a sum or a multiple is 5 over 36 plus 7 over 36, 12 over 36, 1 over 3. So the formula to calculate two non-mutually exclusive events would be P, A, or B would be the probability of A happening plus the probability of B happening minus the overlap, or the A and B happening. Let's say that the Melford newspaper published the results of a recent survey. Are skipping breakfast and skipping lunch mutually exclusive events? So here's your eating habits. 62% skip breakfast, 24% skip lunch, and 22% eat both lunch and breakfast. So let's assume that these are mutually exclusive and that 22% eat both, 62% skip breakfast, and 24% skip lunch. So if this is mutually exclusive, what should all of these things add up to? 100%, exactly. So 62 plus 24 plus 22 equals 108, actually. So that means there is some overlap. How much overlap? 8%. Good. So actually we would need to redraw this as non-mutually exclusive, where 8 is the overlap. Now could you figure out what goes in the rest of these? 16 goes in lunch because it's 24 minus 8 is 16. Yep. 54, because 62 minus 8. Yeah, that's okay. So 54. So are they mutually exclusive? No, there's 8% that actually skip both breakfast and lunch. So part A would be not mutually exclusive. Now B, let's determine the probability that a randomly selected student skips breakfast but not lunch. So probability that they're skipping breakfast but not lunch. Probability of breakfast not lunch is how you'd write that. So that means just in the breakfast circle, not in the lunch circle. 54. Good, because that's just in the breakfast circle. So 54 out of 100. Or 54%. And C, determine the probability that a student skips at least one of breakfast or lunch. So when I figure this out, it's 78% that actually skip one or the other. Because again, 62 was my total that skipped breakfast, 24 was my total that skipped lunch, and then there's 8 that overlap. So we add up our probabilities of our first two and subtract the overlap to get 78%. Now this one's very similar. A car manufacturer keeps a database of all the cars that are available for sale at the dealerships in Western Canada. For Model A, the database reports that 43% have heated leather seats, 36% have a sunroof, and 49% have neither. So again, let's pretend that these are mutually exclusive. So 49% have neither, 36% have a sunroof, and 43% have leather seats. What do these have to add up to? 100. But when we add these up, we actually get 128. So the overlap is the extra 28%, and the overlap is having both. When we say both, that means the overlap. So both would be 28%.